For question 9, we are told that we have a man that is carrying a load on the end of a light stick, and he is resting the stick on his shoulder at point P, which acts as a pivot. He keeps the stick in balance by exerting a downward force F with his hand as shown, okay, and they ask you what is the upward force that his shoulder exerts on the stick. So for this particular question, okay, we can actually solve this by making use of the principle of moments, okay, but we have to draw in the force that his shoulder exerts on the stick first, okay. We are going to draw the force upwards, and we're going to label this as N as our normal reaction force. Okay, so for this, I am going to set the pivot at point F, because point F, because the force of F is a force that I don't know, and I don't really need to know him, okay. So if we just consider the stick which is in equilibrium, okay, and we consider the moments that are created by these 24 newtons and the N force over here, okay, we have this force which provides an anti-clockwise moment and N which provides a clockwise moment. Now, the anti-clockwise moment due to the 24 newtons is going to be 24 multiplied by 0.5 plus 0.3, because the perpendicular distance we need to go all the way back to the pivot. So we have 24 times 0.8, okay, and we have the clockwise moment which is going to be equal to N multiplied by 0.3. Okay, and because we know from the principle of moments, the clockwise must equal to the anti-clockwise, we have N times 0.3 equals to 24 times 0.8. Okay, we can therefore make our cancellations. All right, we have 3 equals to 24 times 8. All right, and we make our cancellation. This means that N is going to be 64 newtons. All right, which is D. There is actually an alternate way in which we can solve this particular question, and that is to make use of both moments and the equilibrium of forces. Okay, so let me just clear the working that we had previously. Okay, so if now instead we set P as our pivot, okay, we set P as our pivot and we take moments about P. So this must mean that F is causing a clockwise moment, whereas 24 newtons is also causing an anti-clockwise moment. So if we take the anti-clockwise moment caused by the 24 newtons, we have 24 times 0.5, and our clockwise moment caused by F is going to be F times 0.3, and if we equate them, we're going to get 0.3F equals to 24 times 0.5. Okay, and solving for F, this gives me 24 times 5 over 3, which I believe is going to be 40 newtons. Now, from here, because the stick is in equilibrium, we know that all the up must be equal to all the down forces. And what are all the up forces? We have the normal reaction force due to the man's shoulder, and that's it. So we have the normal reaction force must be equal to all the down forces, which is the 24 plus the F. 24 plus the F. Okay, so in our previous part, we already solved for F, which is 40. So we have 64 newtons. And you realize that this gives us the same answer as we had obtained before.